Yeah. All right. Here we go. Boom. All right. So we're only going to do 3 basic sections on probability and statistics. So close your lids right now. Thank you. All right, so we'll look at sample spaces and probability functions, figuring out probabilities. We're not going to really look at Venn diagrams so much, but tree diagrams, yep, and conditional probability. Because everybody needs to know what the laws of chances are so they can go to Vegas and see that they can't win. All right. Probability of an event. If an event is finite, if you have a certain number of chances, then the probability of the event is the number of basically favorable outcomes in the event over the total number of outcomes in the event. Okay? So probability is basically number of favorable outcomes over total number of outcomes. This chart is kind of important, okay, because some of the questions will depend upon it. So, what's the probability of rolling a 2 with 2 die? Well, it's 1 on each, right? So there's just 1 opportunity out of the whole 36 opportunities that you have, because there's 6 opportunities on 1 die and 6 opportunities on another die. So the total chances of that is 6 times 6, or 36 different opportunities to get different numbers. Okay? A 2 has to be 1 on each. A 3 could be a 2 on one and a 1 on the other, or a 1 on the first one and a 2 on the second one. So that's why there are 2 chances. A 4 is a 1 and a 3, or a 2 and a 2 on 1 die, or a 3 and a 1. That's why there's 3 chances, and so on. So it goes up. 7 is the most likely number you get from rolling die, because a 4 and a 3, a 2 and a 5, a 1 and a 6, and then on back down with the other ones. Okay? So those are probability distributions for that. Okay? So find the probability of rolling a sum divisible by 4 on a single roll of 2 fair die. Okay? A sum divisible by 4. Which sums are divisible by 4? 4, 8, and 12. So the probability of rolling a 4 or an 8 or a 12. Well, a 4 is a 2 and a 2, a 1 and a 3, or a 3 and a 1. So there's 3 out of the 36. And 8 is a, let's start at the bottom. It's not 1 in anything. 2 and 6, 3 and 5, 4 and 4, 5 and 3, or 6 and 2. So there's 1, 2, 3, 4, 5 out of 36 chances of rolling an 8. A 12, how many chances are that? 1 out of 36. So 3 plus 5 is 8, plus 1 is 9 out of 36, or 1/4 of the time you should get a roll that's divisible by 4. Ta-da! That's what they got. Okay? Probability function is a function p that assigns a real number to each outcome in the sample space. So the probability has to be basically in between 0 and 1, where if it happens to be 1, then it's 100% likely of happening. 0, it won't happen. Okay? The probability of the null set is 0. Okay. Choosing chocolates. Dylan opens a box of a dozen chocolate creams and offers 3 of them to Russell. Russell likes vanilla creams the best, but all the chocolates look the same on the outside. If 5 of the 12 creams are vanilla, what's the probability all of Russell's picks are vanilla? Okay, this is a complicated problem. There is a lot to it. Okay, so first of all, he's going to pick out 3 chocolates, right? Does he replace them after he takes them out? No. So the first chance that he has, because 5 out of the 12 creams are vanilla, okay? The first pick, what's the chances of him getting a vanilla? 5 out of 12. On his second pick, what's the chances of him getting a vanilla? 4 out of 11, because there's only 11 left, and there's only that many vanillas left if he gets the first one. Perfect. Okay. I'm wondering if I'm doing this right. His third pick, if he happens to get the first 2, 3 out of 10. Okay. So if we multiply, I know 5 goes into 10 2 times, 3 goes into 12 4 times, 4 goes into 4 1 time. So you've got a 1 out of 22 chance of that happening. I don't think that's right. No, therefore it's 1 out of 22. Hey, I got it right. Okay. So if there's multiple things happening, then you multiply them if both A and B, if they both happen in the same. Independent events are one thing happens, but it doesn't pertain to the other event. Okay? So those are independent events. So, yeah. So we'll see some of those. And dependent events have A and B, depending on A and so on. So let's look at some of these. Discard. Okay. A pair of die is rolled. What's the probability of getting a 5? Because you got 1 and 4, 2 and 3, 3 and 2, 4 and 1, which is 4 out of the 36 chances, or 1 out of 9 chance. Okay, we good with that. Roll and die. Okay, a sum less than 8. So that's a sum. Can you have a sum of 1? Rolling 2 die, you can't have a sum of 1. So a sum of 2, 3, 4, 5, 6, or 7. 2, there's 1 chance out of 36. 3, there's 2 chances out of 36, right? 4, there's 3 chances. 5, there's 4 chances, right? Right? 6, there's 5 chances, and 7, there's 6 chances. Is that correct? So 1 plus 2 is 3. Plus 3 is 6. Plus 4 is 10. Plus 5 is 15. Plus 6 is 21. So 21 out of 36, which reduces to 7/12, right? Got 7/12 of a chance of that happening. A single die is rolled twice. What's the probability of getting 2 numbers whose sum is 10 or 12? That's really no different than rolling 2 at the same time, okay? Because one doesn't have any effect on the other if you pick it up and roll it again. So the sum of 12, there's just 1 out of 36, right? So there's 2 for 11, and then for 10, there's 3, right? So it's 4 out of 36, or 1/9. Okay. The maker of candy that comes in colors on the right gives a proportion of each color candy. A single candy is drawn at random. Find the probability that the candy will have the following color. Okay? So 10% are blue, 10% are red, 20% are white, 10% are green, 30% are pink, and 20% are tan. What's the probability that it is white or blue? When it's an or statement, okay, that you add them. So white is 1 out of or 2 out of 10 chance, and blue is 1 out of 10 chance. So it's a 3 out of 10 chance, or 0.3, right? All right, now what's the probability that the candy is just blue? 0.1. Now, what's the probability that it's neither green nor blue? Well, the probability that it's green is 0.2. The probability that it's blue is 0.2. You add them up to be 0.4. So not 0.4 is 0.6. So now you're going to draw two of them, because up here we're only drawing one. Okay, so now we're going to draw two. Okay, so you're going to draw a candy out, and then you're going to draw another candy out, and you're not going to replace it. What's the probability both candies are red? Ooh. Yep. So the probabilities both are red. So it's 10% times, I guess you must have to put them back because there's no other way of figuring it out, because it doesn't give you the total number of candies. So 10% times 10% is 1%. You got a 1% chance. So let's look at number 7. Yep, 1%. Okay. All right, what's the probability that one is green and the other is yellow? Green, you got a 20% chance. Yellow, you got a 10% chance. So in the end, it should be just a 2% chance, right? Number 8? Nope. 4% chance. Okay. Oh, because this is your first draw, you got a 20% chance of green and a 10% chance of, what's the other color? Yellow. And then in your second draw, you got a 10% chance of green and a 20% chance of yellow, which is also 0.2. So if you add those up, you get 4/10 of a chance, because it's first pick, second pick. First pick, you have this. Second pick, you have this. Okay? So you're going to take two candies. What's the probability neither candy is green? Okay? So you got an 80% chance that it's not green, and then another 80% chance that it's not green. So then, times. So you got a 64% chance that it's not green. All right. Suppose 5 cards are drawn from a well-shuffled deck. What's the probability that all 5 cards are clubs? Okay. All 5 cards are clubs. Well, what's the chance of getting the first drawn club? 1 out of 4 chance. Okay, because there's 13 out of the 52 cards that are clubs. Then, once one club is out of there, then you've got 12 out of 51 chances, because one is gone. So really, let's go this way so more people can understand. 13 out of 52 chances, and then 12 out of 51 chances, and then 11 out of 50 chances, and then 10 out of 49 chances, and then 9 out of 48 chances. Okay? So if we multiply that all out, 13 out of 52 times 12 out of 51 times 11 out of 50 times 10 out of 49 times 9 out of 48. And then let's go math, turn it into fraction, please. Crap, it didn't do it for me. All right. I can change this in, so if I make the numbers smaller, it might work out better. So that's 1 and 5. 12 goes into 48, 1 and 4 times. 13 goes into 51, right? No, maybe not. 13 goes into 52, 1 and 4 times. Yeah, there we go. Now that we have smaller numbers, we get 99 on the top, and then on the bottom, 4 times 51 times 5 times 49 times 4. 199,920. So you got 99 out of 199,920 chances that all of them are the same suit. Okay, let's check. Ooh, it reduced a little bit more. Both of these must be divisible by 3. So it's 33. Yep, because of the 9 and 51 are both divisible by 3. But it was the right answer. Just got to reduce it. Okay. This one's a good one. If it snows tomorrow, the probability is 50% that John will practice his cello. If it does not snow tomorrow, then there's only a 30% chance that he will practice. The chance of it snowing tomorrow is 60%. What's the probability he's going to practice his cello tomorrow? You're just throwing a number out. Okay, so if it's a 60% chance that it's going to snow, what's the percent chance that he's going to practice? 50, which is 30% chance, right? But you're not done. What's the percent chance that it won't snow? 40% chance. If it does not snow, what's his chances of practicing? 30%, which is another 12% that, wait. Yeah. So then we add them up to get 42%. So there's a 42% chance of him practicing his cello tomorrow. An executive committee consists of 11 members, 6 men, 5 women. 3 members are selected at random from a meeting in Hawaii. The names are drawn from a hat. What's the probability that all 3 are men? Okay. What's the probability the first one is a man? 6 out of 11. Then what's the probability the second one's a man? The third one. So 5 out of 10 is 1 over 2. 6 out of 9 is 2 out of 3. The 2's cancel here. So there's 4 out of 33 chance that it's going to be men. Okay? All right. So